Hi guys, this is chapter 5. We're going to be starting the skeletal system unit, and so let's start to look at bone tissue. So we have, starting off, let's look at this one. So we just want to look at the functions of bone, and a lot of these functions, you guys, it's intuitive and you already know. So we know that the bone supports and protects our body. It protects our soft organs. Our skull is designed to protect our brain. The rib cage protects our heart and our lungs. So it's a protective tissue. It also can act as a storage area. So on the outline, the storage is number 4. Stores calcium and minerals and other than fat. Minerals being phosphate, sodium, things like that. Fat, because there is a yellow marrow inside of your bone which has fat. Your bone marrow also produces blood cells. So number 3 on your functions produces blood cells. And these are all of your blood cells, red blood cells, white blood cells, and your platelets. All those formed elements come from your bone marrow. So the word we use is called hematopoiesis. It's a long word, but it means blood cell formation. So that happens in the red marrow of your bone. And lastly, it provides levers, right? So your bones actually create the joints. The reason why your shoulder joint is so flexible and your knee joint is not is because of the way the bones are fit together. And then you also have tendons and ligaments that bind the bone together. But really it's the bone, right? Your elbows can only hinge. There's only one action at your elbow joint because of the way the bones fit together. So because of the way your skeletal system is shaped, that either limits or gives you more movement at certain joints. So let's take a look at the characteristics and classification of bone. This should be a nice review histology slide, right? We already finished our chapter 3 and 4. Let's look at the way we classify bones. So your bones are broken into the axial skeleton and the appendicular skeleton. The axial skeleton you can see here in green, which includes the bones that form your cranium, or I guess your skull. Your cranium are the bones that house the brain. So these bones are larger and they're a little bit flat, whereas the facial bones are the bones that form your face. But together they form the skull. So your skull is part of the axial skeleton. Your vertebral column is part of your axial skeleton. So remember the word axial means down the midline, right? So this vertebral column, you have your ribs, you have your sternum, you have your sacrum, and you have the coccyx, which is part of your sacrum. And that is basically all of the axial skeleton. The appendicular skeleton, your appendages and everything in yellow. So if you can just remember, what the axial skeleton is, then you know all the other bones are part of your appendicular skeleton. Remember that some bones that sometimes get mixed up are the hip bones, these coxal bones. Those are actually appendicular. They form your hip joint being part of your lower limb. And then the clavicle and the scapula sometimes get folded into the axial, but they're not. They're part of your, they form your shoulder joint, and that's part of your upper limb. So let's take a look at the long bone image here for letter B. The bones are very well supplied with blood. They're very well vascularized. And just one thing to keep in mind, we call these blood vessels that go into bone nutrient arteries and veins, and they are going to run through little holes called nutrient foramen. So you guys will know these words very well in a very short amount of time. But the word foramen or foramen means a hole in bone. If you want to make this a plural word, it's foramina. Right, so this would be holes. So any hole that's in a bone, it's called a foramen or a foramina for many holes. All right, so blood goes into your spongy bone, it goes into your compact bone, it's all throughout, spread out. So when you break a bone, it heals relatively quickly compared to something like cartilage, which does not have a blood supply and heals really, really slowly. So if you had to choose, right, you would much probably rather break a bone or fracture a bone because it can heal very well. Let's look at the composition and structure of the bone. So this is a review from our last chapter, chapter 3, but you should know that your bone is composed of inorganic as well as organic substances, 65% inorganic. This is going to create the hard rigidity of your bone. Letter A, calcium phosphate interacts with calcium hydroxide to form crystals of hydroxyapatite. So these are the crystals that will be found in the bone, and they will again form the strength. Your bones can also contain other minerals such as sodium, magnesium, and fluoride. This inorganic component is very strong, and this is what causes your bones to break if too much stress is placed on your bone. The organic component of bone, 35%, is mostly collagen fibers. So I want to make sure that you guys realize that your collagen fibers are laid down in different directions throughout the osteon. So one lamella or one layer of your osteon will have the fibers running in one direction, and then a different direction in the other lamella, and then a third direction. So what does this mean? What do the different directions of the collagen give to your bone, right? So it gives this flexibility in any direction. So because your collagen fibers are not all in one direction, that means that the collagen can only be stretched in one direction. It has strength in only one direction, just like we remember the dense, regular connective tissue. But since you have collagen running in different directions of your bone, you can put stress in any direction. You can place it from the left, the right, twist a little bit. It can sort of absorb and bend a little bit in different directions. And so that's the significance of the collagen fibers running in different directions. All right, so let's take a look at our next topic, which is the microscopic anatomy or histology of bone. And this should be review. I'm not going to go over this with you guys, but I will introduce the new lamellae. So the chapter 3, I did introduce concentric lamellae, which is the matrix of bone, right? That the stuff that bone is made of, which is the collagen and the hydroxyapatite crystals. Those are laid down in these circles, these concentric circles, kind of like when you drop a pebble into water and it rings out, right? That's a concentric circle. So this is concentric lamellae. However, there's lamellae between your osteons, right? And it doesn't form a perfect circle, but you have to have bone in between the osteons, which is called interstitial lamellae. And then lastly, we have circumferential lamellae, which is going to go around the entire circumference of the bone, right? Which is clearly why it got its name, circumferential. All right, so you guys know the rest of letter D. Let's move on to letter E, the cells of bone. So the cells of bone are found mostly in a membrane of bone, but I want to just introduce the different kinds of bone right now. So there's a stem cell called an osteoprogenitor cell, and it's illustrated here, an osteoprogenitor cell. Let me actually just flip to the next page so you can see these a little bit better. So what you're seeing here is a membrane. You have two membranes of bone. The periosteum is the outer membrane of bone. The endosteum is the inner membrane of bone. So you have membranes inside of your bone lining different regions of the bone. Where you find the osteoprogenitor cells, these stem cells, is within this membrane. You also find these cells called osteoclasts, and you also find cells called osteoblasts in the membrane. Okay, so what I check marked here is found only within a membrane. The only cell that's not inside a membrane, the only cell that's actually in the matrix of bone is your osteocyte. Okay, so your osteocyte is the exception. It is found in the bone, not in a membrane. All right, so again, the osteoprogenitor cell is a stem cell. This is going to, when your bones are building up or when there's repair that's required, the stem cell will reproduce, right? So a stem cell is resting. When it's stimulated to, it will reproduce to form other cells. One cell will remain a stem cell, so you can replenish the stem cell. The other cell will differentiate into a osteoblast. And an osteoblast is going to be a cell that builds bone. So let's take a look at our osteoblast down here. Notice that it's sitting on top of something called osteoid. So osteoblasts, if you look at your notes, number 3, blast means to bud or sprout. It lays down osteoid. So this is your bone building substance. Osteoid is unmineralized organic part of bone. So that 35% organic stuff is coming from your osteoblasts. And so this osteoid is mostly collagen, right? But other organic components too. So what happens is you will lay down kind of this gooey substance called osteoid. Then over time, it'll mineralize. So the calcium and phosphate will come in and crystallize the osteoid, and then that will become a new layer of bone. These osteoblasts build bone in response to a lot of different stimuli, and I do put down that these bones do respond to stress. So if you are weightlifting, your bones can detect that your muscles tugging on the bones more because you're picking up heavier objects, and will actually thicken and build your bone. So you can build thicker bone throughout your life by weightlifting. So that mechanical stress is weightlifting, and also it responds to hormones, predominantly growth hormone, because that hormone stimulates your body to grow. All right, let's look at the next cell, number 4, an osteoclast. So this cell, an osteoclast, is very unusual because it's giant and it's multinucleated. And anytime you see a multinucleated cell, it tells you that several cells, or many cells in this case, came together, fused to form this giant multinucleate cell. An osteoclast is a bone breaker downer. So just think about clast as a catastrophe, that letter C, it breaks down bone. And the process of breaking down bone is called osteolysis. These cells, let me show you this other picture here. So this is an upside down osteoclast. Let me draw an osteoclast right side up. So if I were to draw your bone and then this cell, this giant cell with many nuclei, okay, the ruffled edge of this cell contacts the bone surface. Okay, so you see the ruffling here? Why would you have ruffled, folded edge in contact with the bone? So I mentioned this several times, right? It's to increase surface area. So this ruffledness, make a note here, increases your surface area in contact with the bone. Why? Because it's breaking it down. So it's going to secrete substances. It's going to secrete two things. Oops, sorry about that. I'm going to switch colors here. It's going to secrete enzymes from the lysosome, enzymes. And the enzymes are going to degrade the proteins and the organic part of bone. So the organic, collagen, those will get degraded by enzymes. The other substance that's going to be secreted by your osteoclast is going to be hydrochloric acid. And hydrochloric acid is going to break down the inorganic minerals. So liberate, like dissolve the minerals and get those into the bloodstream. Okay, so why would your osteoclasts dissolve your bone? It's to basically mine your bone for calcium, right, and phosphate, and any other minerals, but mostly calcium and phosphate. So anytime your bloodstream is low on calcium, your bones are a storage site. So these osteoclasts will get busy and store the I'm sorry, get rid of the calcium. It'll reach for the stores and get rid of the calcium. I just want to show you this clip here. So what you see here is an osteoclast, and the osteoclast is mobile, so it can crawl around the surface of your bone. You can see the many nuclei that are present. So this is a fun video of an osteoclast. So a fun thing to think about is that in your body right now, right, there's your bone, you have these cells that are busy dissolving your bone, but you also have cells building your bone, and they're both working at the same time. So your bone never kind of drastically reduces in mass or increases in mass unless you're doing something like weight training, or if you're deficient in calcium, or we will talk about some disorders a little bit later. Okay, so we've talked about osteoprogenitor, osteoclast, osteoblast, and then just lastly, osteocytes. So coming back to this image, your osteocyte, right, this guy here, is going to be embedded in the bone, and it maintains the bone matrix. So it doesn't actually build new bone. It doesn't do anything to take it down. It just maintains the bone. All right, so let's take a look at our next topic, which is our membranes. All right, so like I said, there's two membranes. There's a periosteum and there's the endosteum. Peri means around, like the periphery. It has that same root word, P-E-R-I. And this is going to be around the outside of bone. So let's take a look at our periosteum right here. There's two layers to the periosteum. The outer layer is going to be fibrous, so it's very tough. When you see the word fibrous, you're going to think very tough, dense connective tissue. So if you look at letter B in your outline where I say the outer layer, I have it's fibrous and tough. It attaches the bone to the connective tissue network. It helps to stabilize your joints. It helps to stabilize your bone to muscle attachment. So it basically can reach out to other tissues and connect that tissue to the bone. The inner layer is nothing like that. The inner layer is very soft and thin. And this is where you have your bones, your bone cells that I was talking about. So this is where you have your stem cells, the osteoprogenitor cells. This is where you have your osteoblasts, and this is where you have your osteoclasts. So we call this layer, your book calls this layer the osteogenic layer, genic meaning genesis, right? So if you want to build bone, osteo referring to bone, this is the layer that helps you build from the outside. Now, let's look at the endosteum. The endosteum is very similar to the osteogenic layer. I don't think I have a picture of the endosteum, but this is actually the endosteum here. So the endosteum is going to be found in different areas of the bone. It's a membrane that is not complete, right? It's incomplete, meaning that there can be some gaps in the endosteum, but it does contain your osteoblasts, your stem cells, and your osteoclasts. So the same three. I want to show you where you find your endosteum, and it's listed in your outline. So number one, it's found on the trabecula of your spongy bone. So the membrane, you can actually kind of see how this illustration is creating a little membrane that's on top of your trabecula of spongy bone. It also lines your central canals. So every single central canal of an osteon is going to have a lining of endosteum. And then it also lines the medullary cavity of a long bone. So to give you an illustration of that, because we haven't covered medullary cavity yet, the medullary cavity is the central space inside of a long bone. So any bone that is longer than it is wide is considered a long bone. And long bones are found primarily in your limbs, from your humerus and your forearm bones, your thigh bone, your leg bones, your fingers, the things called metacarpals or metatarsals, those are long bones. They all have a space called the medullary cavity, and that's lined with endosteum. So when you build or break down bone, you do it at the membranes. You do it at the periosteum on the outside layer of bone, or you do it on the endosteum in the areas that we just talked about. All right. So I'm just going to go to see, I have a question for you here. Go ahead and pause it. All right, the answer is osteon. So I know I didn't cover this explicitly, but the basic functional unit of bone is the osteon. All right, go ahead and think about this one. Pause. The answer is letter D, because that's the definition of what was on the other slide. And the other questions, right, if you ever see outer, endosteum is within, so outer is wrong. This is describing the fibrous layer of the periosteum. This is also outer again, so we know that's incorrect because endosteum is on the inside. All right, we're going to pause for part one, so that's the end of part one.